Today we're going to talk about the laws of logarithms. Don't forget your stat box. And so we've got C1, laws of logarithms. So we will be talking about the laws today, and then we'll use the laws in a little bit of a different way tomorrow for C2, kind of use them with equations. But it's important that we get all these laws down today. So we're going to have a similar screen that looks just like this, but first of all, we've got the laws for base 10. And so I don't think you really need to write them down twice because we're going to look at them on this screen and the next screen. But one thing is that if both A and B are positive, so I've got whatever I'm taking the log of here and here, those are both positive numbers, and they have the same base, right? We know if there's no base that they're both base 10. So if I'm adding my separate logs, I can put them into one log by multiplication. So that's like our first law is if we're adding separate logs with that same base, we can put them together using multiplication. If we're subtracting logs that have the same base, we can put them together in one single logarithm by using division. So it's always the first part divided by the second part. And then if I've got a number multiplied to my log, if I want to put that in the log, it becomes a power on what's in my log then. So it's not the log of the whole thing, but it's a power of what you're taking the log of. These look a little bit familiar from last year. So all of these are in base 10, but what we have on the next screen is that all of these laws work the exact same way if we have other bases as well. So if you don't want to rewrite it, and if you're not done writing, you'll be fine. These are all the exact same, but the only difference is instead of having nothing here, there's little C's, showing that it just has to be the same base. So it could be 2 and 2, 3 and 3, 17 and 17, whatever it is, but it's the same exact laws. So they work for base 10 and any kind of base. It's just that when you're combining them, the two have to have the same base. So if it was like a 3 and a 2, that would not work out. But if they're the same, then we can combine them just like we were talking about on a previous slide. Good news, this is in your packet. Almost exactly like this. The only difference is in your packet they use an R on this last one instead of an N. Otherwise, it's exactly the same. So you don't have to memorize it, but you do have to know how to work with it. So we're going to do like 4 examples working with some of these, take a break from the stat box, and then we're going to do like show that problem in something a little bit different. Are there any questions? Okay. So we're going to have a bunch of examples, and the first 3 examples are going to have these directions. Write as a single logarithm or as an integer. At times you'll see that it'll simplify to be just a number, but otherwise we want to write as a single logarithm. And the first one is log of 4 plus log of 5. And then the first thing we really look for is, do we have the same base? Sure enough, there's no base listed, so we know that means base 10. So since I have the same base, I can combine them into a single log, and I have to multiply what's inside my log, so 4 times 5, which would just be log of 20. So we can definitely simplify that, but I just want to show you all those steps in between as well. So again, when we're adding, we want to bring it to a single log. We multiply what is in those logs. We're going to do another one that just looks a tiny bit different, and we're going to have to remember some things from last week, Wednesday. But are there any questions so far? Try. All right, same directions. Write as a single logarithm or integer. 2 plus the log of 2. So the first thing we look at is, do we have logs that have the same base? We don't, because we just have one log. The answer is not log 4. So what we have to do is we have to take 2, and we have to write it so that it has a base 10. So remember, there's like an invisible 10 there. So something we talked about is that if I have a base, and then I have kind of like the base here, those would cancel out. So I can rewrite 2 is log base 10 of 10 squared, as long as these numbers match. If the base on your log is the same as this number, those are equivalent. So we did talk about that on Wednesday, and I said like put a star by it in your notes. We're going to come back to it. That if you've got that same base here, these are equivalent. And I could really use any base. Like I could say log base 7 and 7 squared. That's the same. These are the same. I could say log base x and x squared because these are the same. In this case, I'm using 10 because I've got the 10 right here. But just kind of keep that in mind that I can write that as this other way. Do you guys remember what I'm talking about from your notes on Wednesday? From 4A? If not, look back. Like I know I said star that. We're coming back to that. So then this is still log base 10 of 2. Now I don't really need those 10s anymore, but it's nice to kind of see that. So now when we're adding, we know we have to multiply. So I've got log of 10 squared times 2. So again, that adding, I have to multiply what is in both of my logs. So I can simplify that a little bit further. And 10 squared is 100. 100 times 2 is 200. And you don't have to have the 10, so whether you have the 10 in there or you don't, either way is really fine for that. Any questions? Are you guys with me? When we put our heads down, I feel like you're not with me. Am I going too slow? I just want to make sure that you guys are all good. Like I said, I feel like people generally freak out about logs, and I don't want that to happen. So I've got same directions, right, as a single logarithm or integer, and I've got 5 log 2 minus log 3. So we're actually going to use 2 different laws in the same one here. I noticed right away that I don't have a base, so that means they're both base 10, so I don't have to worry about not being able to put them together. They're both base 10. I can't start dividing right away because I have this number, so I have to remember that law so that I could write that as an exponent. So we'll go ahead and we'll have log of 2 to the 5th power minus log of 3. So once we have that as part of our log, we're taking the log of 2 to the 5th power, then we can use our other law. And I don't care if you simplify this here or on a future step, so I'm just going to go with the logs. And remember, when we subtract, we have to divide. So I'd have 2 to the 5th power divided by 3. So when I'm combining them, that subtraction, we end up dividing what we're taking the logs of. So 2 different laws, and then if I do simplify, 2 to the 5th power is 32. So I have a log of 32 over 3. So not the cutest thing in the world, but it's all right. It's doable. The next one is going to be a little bit different. So are there any questions so far? You feel like really good or really not good? Guys, you look like you feel asleep. Okay. All right. Alright, so the directions are different, and it does say simplify without using a calculator. So I don't want you to take your calculator and pop that in there. What we want to do is we want to try and simplify it by hand. And so when we see like a fraction like that, I'm thinking that maybe down the line something will cancel out. But what would not happen is this is not equal to 1/2. Okay? We can't just start saying like, oh, well, yeah, that's 8/16, that's 1/2. We can't do that because the 8 is part of that log. The 16 is part of that log. So I cannot just start canceling that out right away. We want to have some groups that are like exactly identical that we can cancel out. So if I look at the numbers 8 and 16, what do they have in common? What was that? What are you thinking? Yeah, exactly, too. Last hour, someone said they both have 8 in common, which is true. They both have 8. But if we think back about some of that stuff that we worked on last chapter with those powers, they're both powers of 2. So we can use that. So I'm going to go ahead and change them both. So I'm going to change 8 to 2 to the 3rd power. And then I'm going to change 16 to 2 to the 4th power. Because now it's looking a little bit more similar, right? We still can't just cross things off quite yet. But what we can do now is we can use one of those laws in reverse. So we can use those laws that go forward and backward, right? So I can put the 3 out front, and I can put the 4 out front. And that's like a multiplication. So I've got 3 times the log of 2. And 4 times the log of 2. And because these are they're separate because they have the multiplication, those both cancel out, and all I have left is 3/4. So that one actually simplifies just to being a number. But just keep in mind, it's like I said, we can't just start crossing them off right here. We have to get it so that these groups are identical before they can cancel. We're going to stop at the stop box, and we're going to have 2 more examples that are like a little bit different. I know this one is a little bit strange too, but are there any questions about it and about those strategies? Alright, so like I said, this is in the formula packet, so you don't necessarily have to memorize it for this class, but you know, if you are taking the ACT or you're taking your college entrance exams and stuff like that, you can't use a packet. So any ideas of how you might remember these laws? Plus, I mean, your work will go faster if you don't have to like have a packet in front of you and look at that all the time, right? So any thoughts? Also, I was thinking that last year you probably couldn't use a packet, right? And Shwigna made you memorize these? Am I right? You didn't really do note cards or anything, did you? Okay. So does anyone have any ways? Anything that they do? So what I do is the connection between like the exponent laws and the log laws. So like if I have x to the a times x to the b, I know I add them, right? So there's like a connection between multiplying and then adding. And we know that logarithms are the inverse of exponential. So for me, I think, okay, well, it kind of works backwards. Where if I'm adding, then I can change that into using multiplication. So I don't know, that's just what works for me because we already have these memorized. We've been working with the exponent stuff since you guys are in Algebra 1, whenever that was. So I kind of transfer that knowledge. And then, again, it's in your packet, I know, but that's what sort of helps me remember all of those because it works for like the division and the subtraction as well. I don't know if I have a good one for the law with like the powers. I'm not sure if I have a good way for that, but it works for the other 2. All right, so just 2 more examples. Starting off with a show that problem. So just like the ones we worked on the warm-up today, I know that there are some of you that are going to look at this and just think, well, duh, I can do that in my head. I understand that, but on a show that problem, we've got to see all of those steps. So even if you can do all that work in your head, and the show that problems vary in difficulty. This one is more on the basic side, but kind of keep in mind that we've got to show all of our steps. Also, different strategies you might use if you're trying to like start at the beginning and then work towards the end. If that's like not working for you, you can always work backwards. You could take this side and then you could go, from here to here if you need to. It doesn't matter which way you work as long as you show all the steps in between. So if I take a look at this, I notice that I have a square root, but I know I can do something with powers, so I'm going to write that square root as a power. And then I know I can use that law to bring that power out in front, so kind of using it in reverse. And I got it. So there you go. That one is not too bad, right? Keep in mind when you guys approach these that you might not get it that quickly. It might not go well right away. You might have to start it and erase it and come back and all of that. So if you get stuck, ask me for a hint. I'm not going to tell you the answer right away, but I'll give you a hint. And then if it's still not coming, let me know and we can work through that. The last one we've got for an example is just a little bit different. And it tends to be really confusing to students at first. So let's make sure we take a look at it. It's saying that P equals log base B of 2, Q equals log base B of 3, and R equals log base B of 5. Write in terms of P, Q, and R. I think this one might be a little bit more difficult, which actually might make it easier to understand because I see a lot of students sort of substitute inappropriately on these types of problems. We have to really look for, if I've got log base B of 2, then I can use P. If I've got log base B of 3, and log base B of 5. So I really have to look for those exact expressions before I can substitute. And I see my question is log base B of 45. Well, looking at those numbers 2, 3, and 5, can I somehow get 45 out of 2, 3, and 5? Like, how could I kind of break 45 down using the numbers 2, 3, and 5? And you might not even need all of the numbers, by the way, but this is what I've got to work with. So how can I write 45 as a combination of these numbers? Like how could I maybe use those numbers to multiply to equal 45? Wait, what? Did you say 5 times 9? Yes, good. That's what I thought you said. Perfect. 5 times 9. So I've got 5 times 9. And 9, we know we can make up with 3, right? 3 squared is 9. And there is more than one way to do this as well. Someone kind of came up with something similar that would end up with the same answer in my second hour. But I can break that down. So I can break that down to 3 squared. So now I've got 5 and 3, 2 of my numbers. So again, I'm looking at, okay, what do I have to work with? I can work with 2, 3, and 5. I can make 45 from 5 times 9. Now I can use my law in reverse. So I can take this multiplication and split it up into 2 logs that are adding. So I'm using that law in reverse. Are you guys okay with that? How we can use them both ways? Now this one's pretty good. I could sub R right in for this, but I'm going to wait to the last step and do my substitutions together. This, not quite, because I have to get that 2 out of there. It's not going to substitute in with that 2. So I have to move that 2 out front before I can substitute. So I have log base B of 5 plus 2 times log base B of 3. Because now I see this is exactly that. This piece right here is exactly this. So now I can substitute in this spot. I can write R. And then in this spot here, I can write Q. You could have also had it the other way, like I think last hour we had it the other order, so we had 2Q plus R. But we know the commutative property works, so we don't have to worry about that. But again, make sure that you're not just plugging it in willy-nilly. It has to be exactly that same expression that's up here before you can substitute. And I'm thinking of things you guys are going to see in the future and things you guys are going to see on your tests and stuff, and just mistakes that happen. I'm trying to stop them now by being very clear. So maybe it's not seeming too crazy now, but just kind of keep these things in mind as you move forward. Are there any questions? All right, so here is the assignment. We've got about 20 minutes to work in class.